Hello students, welcome to Mathalite. In this video, we'll derive the formulae for surface areas and volumes of sphere and hemisphere, for which we have considered a sphere. Okay, this green colored ball is a sphere. There is another sphere, orange colored ball having same radius, that is same surface area, same volume as that of this green ball. Okay, only thing is I've cut this ball into two halves. Okay, almost two equal halves. So two hemispheres, and we have a sphere over here. All right, now we know the surface area of a sphere is 4 pi r square. Why? Let's see. Now simultaneously we'll have a look at the surface area of hemisphere as well. Okay, so over here we are taking four circles. Okay, these four circles have same radius as that of this hemisphere and sphere. This hemisphere and sphere, you can see same radius hai. Okay, and this blue circle has same radius as that of this orange ball. Okay, so I'll confirm this by placing this circle on this hemisphere. So you can see it is covering the hemisphere same way, right? So same base area hai, that is same radius. Okay, so these four circles, what will be the area of these four circles? One circle has area pi r square, so area of four circles is 4 pi r square, right? Now we know surface area of a sphere is 4 pi r square, and curved surface area of hemisphere is 2 pi r square, right? And total surface area will be 3 pi r square. So let's see why. For which we are going to take two wires. Okay, I have coiled these wires. There is a green color wire, black color wire. मैंने coil करके tape कर दिया है because this was opening up. So I have coiled it, okay, and taped it. Now, placing these wires on this sphere. Before that, let's have a look at the area of this wire, black wire and green wire. You can see this black wire has same area as that of this circle, right? ये circle का जो area है वही ये wire का area है. So the area of this wire is pi r square, right? Same way, this green wire. Okay, don't look at this white portion. Tape बाहर आ गया है, ठीक है? So forget that part. The green portion, the green wire, and this circle. Okay, same area. Okay, so I'll just place this green over this black. ठीक है? So you can see same area है. ठीक है? So pi r square, 2 pi r square. Now 2 pi r square means it should cover half the sphere, that is it should cover half the ball, right? If it covers half the ball, I can say remaining half can be covered by these same wires, right? So total area should be 4 pi r square. So these two, the total area is 2 pi r square. So when I place it on half of the sphere, it should cover half of the sphere basically, right? So I can say half of the sphere has area 2 pi r square. So therefore whole will have 4 pi r square. So for that we'll place this black wire along with this tape. ये मैं बाद में place करती हूँ, पहले मैं green wire को पूरा coil up कर देती हूँ, ठीक है? Around this sphere. So I'm opening the tape. So you can see over here there is a line running, okay, from the middle. So it shows that it is divided into two equal parts. So these two wires should cover half of the sphere, right? That is 2 pi r square. So you can see I have to hold it tightly, students, because it might open up. So now taking this black wire. So you can see this black wire, actually I've taped it. If I remove the tape, if I just remove the tape and then place it, there's a curvature over here, which is the reason it is difficult to place. So you can see अब gaps बढ़ गया है. So that was the reason I taped it. So these two wires, okay, they cover half of the sphere. All right, they cover half of the sphere. So basically half of the sphere has area 2 pi r square. So full sphere will have the area 4 pi r square, right? So this did not work out as I had planned, so I'm very sorry for that. So I'll just bring a close up shot. ठीक है, so ऐसे हो रहा है. You can see there are gaps in between, this which is the reason वो green wire के ऊपर overlap हो रहा है थोड़ा सा. ठीक है, so ये part में gap रह जा रहा है. Now this is the area of the half of the sphere, okay, which is 2 pi r square. So area of the full sphere will be 4 pi r square. Now we know that the curved surface area of the hemisphere is 2 pi r square because it is half the area of the sphere. Okay, if you cut the sphere into two equal halves, then the area of the hemisphere, curved surface area of hemisphere will be 2 pi r square. And double it up, combining the two hemispheres, you will get a sphere. Okay, you will get a sphere. So the area of the sphere will be 4 pi r square. Now, in case of hemisphere, there is total surface area as well. So, if you consider curved part as well as the base part, so if the hemisphere is like this, curved part as well as a flat base, then what will be the area? The total surface area of this hemisphere will be curved area plus this flat surface ka area. What is the area of this curved part? 2 pi r square, right? And what is the area of this flat part? Pi r square. So 2 pi r square plus pi r square, that is 3 pi r square. Okay, so hemisphere ka curved surface area 2 pi r square and total surface area will be 3 pi r square. All right, so I hope it is clear to you, students. Now let us see why the volume of a sphere is 4 by 3 pi r cube. Once we get the formula for volume of sphere, we know that hemisphere has half the capacity of the sphere, right? Because the sphere is being cut into two equal parts, so it will have half the capacity of the sphere. So why is the volume of the sphere 4 by 3 pi r cube? Once we get that, we know the volume of the hemisphere will be 2 by 3 pi r cube, half of that, right? So let's see why. For which we will consider two other shapes, a cylinder and a cone. Okay, now there are some dimensions kept in mind. Okay, so over here we know this circle has same radius as that of the sphere. So circle and the sphere have same radius. Now this cylinder and this circle also have same radius. Okay, so radius of the cylinder is same as that of this circle. Same way, this cone also has the same radius, okay, as that of this circle. So basically the cone, the cylinder and the sphere have same radius, okay, same radii. Now coming to the height, because when you consider the volume of the cylinder and volume of the cone, height is important dimension. So over here the height of the cylinder is twice the radius. Okay, so height of the cylinder is twice the radius, even the height of the cone is twice the radius. So जो भी इसका radius है उसका double height है. Same way जो भी इसका radius है उसका double height है. And we know the radii of all the three shapes are same. We have taken it as same. So over here circle which has same radius. Now let's confirm this. So you can see the radius, this is the radius length. Okay, ये radius का length है and ये जो height है triangle का, this is the diameter of the circle, that is twice r. Okay, so this height is nothing but twice r. Okay, So height of this cylinder, okay, height of this cylinder is twice the radius. Same way, height of this cone is twice the radius. So I'll show this in a better way, ठीक है, ऐसे. So according to that the slant height is chosen. So this is the slant height of the cone. Okay, ये जो slant height है, it is taken according to the height and the radius. Okay, so height of the cone and the cylinder is twice the radius. Now since height is twice the radius, what will be the formula for the volume of the cylinder and volume of the cone? Volume of the cylinder is pi r square h. So it will be 2 pi r cube, right? If you take h as 2r, then it will be 2 pi r cube. Same way, volume of the cone, it is 1 by 3 pi r square h. So it will be 2 by 3 pi r cube if you take h as twice r. Okay, so it will be 2 by 3 pi r cube. This is 2 pi r cube. Now, volume of this cylinder, okay, this cylinder will be equal to the volume of the cone plus the volume of the sphere. Okay, this sphere is cut into two halves, so दोनों का volume add up करे तो it will be volume of the sphere. Okay, so volume of this sphere plus volume of the cone is equal to the volume of the cylinder. Let's check. So I've taken some tea. Okay, I'll fill it in this cylinder, or first let me fill it in these two hemispheres and this cone, and then I'll pour it into this cylinder. All right, so you can see that I have filled this cone, the two hemispheres, that is the sphere. So volume of this cone plus volume of the sphere should be equal to the volume of this cylinder. Okay, so let's pour the tea into this cylinder. Okay, so all right, now pouring. So you see, it is filling up the cylinder. So volume of the cone plus volume of the hemisphere. Okay, volume of this cone having height twice its radius plus volume of this sphere is equal to the volume of the cylinder, which again has the height which is twice its radius. So if you add up the volumes of these two shapes, it is equal to the volume of this cylinder. Now solving this, what will you get the volume of the sphere? Volume of the sphere will be 4 by 3 pi r cube, right? It will be 2 pi r cube minus 2 by 3 pi r cube, which gives you 4 by 3 pi r cube. So therefore the volume of the sphere is 4 by 3 pi r cube, and hemisphere will have half the volume, which is 2 by 3 pi r cube, right? Now if you consider a spherical shell, that is a sphere which is empty from inside. Okay, so spherical shell hai. Now what will be the volume of this spherical shell? That is, what is the volume of the plastic used to make this shell? Okay, this whole shell will be a sphere. Okay, so what will be the volume of the plastic required to make this spherical shell? Very easy. What is the outer volume of this sphere? It is 4 by 3 pi r cube. Okay, it is 4 by 3 pi r cube. Let's say that the outer radius is capital R. All right, so it will be 4 by 3 pi capital R cube, and this plastic ball has some thickness. Okay, it has some thickness. Now therefore inner radius will be little less than the outer radius, right? Inner radius will be less than the outer radius. So inner radius, let's say it is small r. So what will be the inner volume of the internal volume of this sphere? it will be 4 by 3 pi small r cube, right? So internal radius we have taken as small r. So it will be 4 by 3 pi small r cube. So what is the volume of the plastic required? It will be outer volume minus inner volume. Okay, बाहर का जो भी volume है, okay, that is 4 by 3 pi capital R cube and minus the internal volume, which is 4 by 3 pi small r cube. So that will give you 4 by 3 pi capital R cube minus small r cube. Okay, so that is why the volume of the spherical shell will be 4 by 3 pi capital R cube minus small r cube. All right.